Here are 32 or 131, depends on how you want to count them, concepts to help you write maintainable code or easier to maintain code. 0. Maintainable code is easy to understand code and code with plenty of unit tests. 1. Maintainability comes in small packages. Keep functions and classes small. Do one thing in a method or class. Aim for 5 lines per function and 50 lines per class. 2. Indirection. Indirection is the ability to reference something using a name instead of the value itself. Use indirection to replace code with a method call. 3. Extract method and extract class. The most important refactoring techniques for writing maintainable code. This is applied in indirection. 4. Beautify code. Replace hard to understand code with a well-named method that explains what the code does. Works especially well with conditionals, the part between the parentheses after the if. 5. Take advantage of naming things to express intent. Naming things allows you to express yourself almost with free speech. Err on the side of being verbose rather than cryptic. Keep often used public methods names small though. 6. Less parameters is better than more parameters. Use introduce parameter object to make a data class that holds the parameters together. 7. Single responsibility principle extended. A class should do only one thing. A function should do only one thing. A row of code should do only one thing. 8. Low coupling, high cohesion. Your classes should be coupled or use or know about other classes as little as possible. The things that happen in your class should be related to each other as much as possible. 9. Command and query separation. There are 2 types of functions. Queries are getters or methods that calculate something. They only return and don't change the state of the system. Commands change the state of the system and don't return anything. 10. Tell, don't ask. Avoid asking objects what their state is and tell them what to do directly. Use encapsulation. 11. The law of Demeter. You may only call methods on objects that were available when your function started or that you created. You may only call methods on parameters, your class properties, globals, and on objects you created. 12. Encapsulation is a friend. Use encapsulation making methods and properties private with no setters and getters as much as possible. Hide your state. Make your objects smart. 13. Abstraction or modeling is a friend. Abstract or model the real world in your code. Printer.print, dog.bark. 14. Composition is a friend. Inheritance is not. Use composition, where a class has an instance variable of another class. Try to stay away from inheritance except for very simple classes. Inheritance is too rigid. 15. Polymorphism is not always a friend. Don't use polymorphism if it leads to complex code. 16. Data objects are a thing and they are okay. There are 2 types of objects. First, classic objects that model the real world and encapsulate their state. They are smart objects. Second, data objects or data classes. Second, data objects or data classes that only hold data and maybe some basic data related functionality. They expose their state. They're dumb objects. Data objects have their use, even if they seem to break object-oriented programming principles. 17. Know about the pattern types. Creational patterns like builder, factory, and singleton. Structural patterns like adapter and proxy. There are behavior patterns like null object and observer. Concurrency patterns like coroutine and thread pool. Architectural patterns like MVC, client server, and inversion of control. 18. Use simple patterns. It's okay to use or recognize simple patterns like singleton, builder, wrapper, observer, MVC. 19. Stay away from complex patterns. Complex patterns can kill your project, especially poorly implemented complex patterns. 20. Always use test-driven development. Write a small test just enough for it to fail. Write code just enough for the test to pass. Write a small test just enough for it to fail, and so forth. 21. When not using test-driven development, use high-level first. Write the high-level algorithm with function calls to non-existing functions that you implement later. 22. Use continuous refactoring. Always refactor. Refactor when reading code, refactor when changing code, refactor when you are not even at your PC. 23. Solid programming. S stands for the single responsibility principle. A class should only do one thing. It's a great concept. O stands for open-close principle, open for extension, close for modification. Be careful so you don't implement complexity to follow it. L, list of substitution. Child classes should be able to do everything their parent does. It's a decent concept, proof that inheritance is evil. I stands for interface segregation principle. Many client-specific interfaces are better than a generic one. It's a decent concept. D, dependency inversion principle. Depend upon abstractions, not concretion. I disagree with it. May Uncle Bob forgive my sinful keyboard. Use concretion unless you have a specific reason not to. Concretions are far more familiar. 24. Clean code. See also everything from Uncle Bob regarding clean code. First, keep functions and classes very small. Give proper names. Methods should start with a verb. Classes and variables are nouns. Boolean variables and methods should start with is. Verbose versus public methods. Err on the side of being verbose, except for often used public methods. Keep the parameter number small. Follow your IDE guide about the line of code length. Beautify code, don't use comments. Exceptions are fine if your methods are small. Don't use checked exceptions. 25. Object calisthenics. From the book The Thoughtwork Anthology. Number 1. Only use one level of indentation per method. This forces you to use extract method a lot. 2. Don't use the else keyword. It's a hard one. You will have to rely on return and null object a lot. Introducing a new variable and polymorphism, I think, brings too much complexity to be good solutions. 3. Wrap all primitives and strings. The idea is to encapsulate your primitives into objects. This might draw behavior and turn them into smart objects and takes the defense against primitive obsession to the extreme. 4. First class collections. A class that contains a collection should have no other properties. This is a good one. 5. One dot per line. This would be minus greater than per line in PHP. So basically, don't use methods and properties on objects you obtain from other objects. This prevents train wrecks or message chains. It also forces you to follow the law of the meter. It doesn't mean you should just go on the next line. 6. Don't abbreviate. Decent naming advice. Err on the side of being verbose when naming things. 7. Keep all entities small. Keep classes under 50 lines. Maintainability comes in small packages. 8. No classes with more than 2 instance variables. It's a hard one. If you only have 2 instances, you will be forced to keep your class small. Also, your cohesion will go through the roof. You will end up with a lot of classes though. Tons of well-named methods are a good thing, but this might be artificial and counterproductive when applied to classes. 9. No getter-setter properties. Hard one. Maximum of encapsulation. Everyone hides their state from the world. Data classes should be an exception. It also promotes tell don't ask and the law of the meter. Generic concepts. 26. KISS. Keep it simple, stupid. The simpler your code is, the more maintainable it is. Complexity is expensive. Complexity kills maintainability. 27. Yakni. You ain't gonna need it. Do the simplest thing that could possibly work. Don't implement things that might be useful someday. Don't prepare for things to come because they might not come. 28. Dry. Don't repeat yourself. Use extract method. 29. 80-20 rule, or the Pareto principle. 80% of consequences come from 20% of the causes. 80% of functionality comes from 20% of the code. So it's worth writing that code first and getting feedback. 80% of the bugs come from 20% of the code. So it's worth refactoring and testing more there. 30. Code smells. This is from the book Refactoring by Martin Fowler. These are like bad patterns you find in code or code smells. 1. Duplicated code. Use extract method. 2. Long method. Use extract method. 3. Large class. Use extract class. 4. Long parameter list. Use introduce parameter object or replace parameter with method. 5. Divergent change. One class is changed in 2 different ways. Use extract class. 6. Shotgun surgery. A change requires a lot of little changes all over the place. Reorganize code for more cohesion. Use move method. 7. Feature envy. A method is more interested in another class rather than its own this class. Use move method or extract method. 8. Data clumps. Some fields seem to naturally group together. Use extract class to put them in the same class or introduce parameter object. 9. Primitive obsession. Using a primitive that should be better off in a class, usually because of a fear of objects. Use replace data value with object. 10. Switch statement. Use polymorphism. I disagree with this one. Leave the switch alone, just use extract class to make it small and obvious. 11. Parallel inheritance hierarchies. Every time you change one subclass, you have to change another parallel subclass. Use move method. 12. Lazy class. A class that isn't doing enough to be worth having. Usually a side effect of refactoring. Use inline class. 13. Speculative generality. You make complex generalizations to support use cases that aren't required yet. Use Yagni and don't do it. 14. Temporary field. An object in which an instance is set only in certain circumstances. Use extract class and introduce null object. 15. Message chains. An object asks one object for another object and another. Also called train wrecks. Use hide-delegate or extract method. 16. Middleman. The opposite of message change. Too much encapsulation leads to a lot of middlemen hiding the chain. Use remove middleman or inline method if possible. The last two are opposites. Use common sense. 17. Inappropriate intimacy. When a class knows too much about another class. Use move method, move field, extract class to increase cohesion. 18. Data class. A class with its state exposed and little behavior. I disagree with this being a code smell. Data classes are fine. 19. Refusal bequest. A class refuses functionality from its parent. This breaks Liskov substitution. Use composition over inheritance. 20. Comment. Comments mean you fail to express yourself with code. Use extract method and take advantage of naming things to express yourself. 31. Refactoring techniques, composing methods. This is also from Refactoring by Martin Fowler. 1. Extract method, the most important refactoring technique. Basic use of indirection applied to code using functions. 2. Inline method, opposite of extract method. This should be used very rarely. 3. Replace temp with query. A temp variable is assigned from a simple query and is getting in the way. Replace it with the query everywhere. Use with caution, it doesn't always apply. 4. Introduce explaining variable. Put an expression value inside a variable and take advantage of the variable name to explain what you are doing. Consider if it would be better to use extract method, which would have other advantages also, like increased cohesion and movement towards single responsibility principle. 5. Split temporary variable. A variable is assigned more than once, not inside a loop or collecting a temporary variable. Split it into multiple variables with proper names. 6. Remove assignments to parameters. Don't assign values to parameters. It introduces confusion. Use a temporary variable instead. 7. Replace method with method object. Long methods is where objects go to hide, said Uncle Bob. Replace a long method with an object. After all, it is big enough to have a proper state and private methods. Do this when extracting method is not more convenient. 8. Substitute algorithm. Replace an algorithm with another one that is clearer. 9. Move method. A method is using another class more than its own. It suffers from feature envy. Move it to the class it is envious upon. 10. Move field. A field is used by another class more than its own. It is the focus of envy. Move it to the other class that uses it more. 11. Extract class. When a class does too much, extract a class from it. The equivalent of extract method but for classes. 12. Inline class. The reverse of extract class. Be careful with this, it's usually a step in the wrong direction. 13. Hide delegate. Encapsulate to avoid train wrecks or message chains, even if just using wrappers. From object A, you get object B, from which you get the object C to call the method X. Encapsulate the state of B. Add to it method X, even if it's just a wrapper for C.X. Remove middleman, the opposite of hide delegate. You find the right balance between the two in time with refactoring. 15. Introduce foreign method. An external class you can modify needs an additional method or functionality. Create the method in your class with an instance to the external class as the first parameter. 16. Introduce local extension. An external class you can modify and use more functionality. Create a wrapper class. 17. Self-encapsulate field. Add getters and setters. 18. Replace data value with object. You have a data item, primitive, language class that needs additional data or behavior. Turn the data into an object with that data as a member. 19. Change value to reference. You have a class with many equal instances. Replace those instances with a single object referred by everyone. Instead of multiple new year 2020, use only one factory, for example, that returns the same year 2020. 20. Change reference to value. The opposite of change value to reference, when a single instance is awkward to work with. 21. Replace array with object. An array has elements that mean different things. This means low cohesion. Turn the array into an object with a field for each element. 22. Duplicate observed data. You have data in the GUI that you need in your domain. Copy the data in the domain and create an observer to synchronize. Kind of sketchy and complex. Use with caution. 23. Change unidirectional association to bidirectional. Two classes use each other's features, but only one has a reference. Create a reference in the second class. Change bidirectional association to unidirectional. The opposite of change unidirectional association to bidirectional, when a bidirectional association is not needed. 25. Replace magic number with symbolic constants. Never use numbers and strings in code as types or special meaning. Use constants instead. 26. Encapsulate field. Make fields private and add getters and setters. Basically the same with 17. Self-encapsulate field. 27. Encapsulate collection. Instead of returning a collection, return a read-only view and provide add remove methods. 28. Replace record with data class. Put records from APIs or databases into data classes with proper fields. 29. Replace type code with class. Instead of keeping strings and numbers for center types like blood type, move them into their own blood type class. 30. Replace type code with subclasses. Subclasses, as in classes that extend the main class. Be careful though, because inheritance can turn against you. Instead of employee type developer int1 and type manager int2, developer and manager extend employee. 31. Replace type code with state strategy. Like the last one, but don't extend directly employee. Create an employee type extended by developer and manager, used by employee with composition. 42. Replace subclass with fields, the opposite of the last one. Refactoring techniques simplify conditional expressions. 33. Decompose conditional, same as beautify predicate. Move predicates, conditionals, the part inside the if, into well-named methods. 34. Consolidate conditional expression. Same thing happens after a number conditionals, like all return 0. Extract them inside the well-named method, extract method and beautify code to the rescue. 35. Remove control flag. You have a variable that is acting as a control flag for a series of Boolean expressions. Use a break or return instead. 36. Replace nested conditional with guard clauses. Basically, return early. Get the exception cases out of the way with returns to avoid complex conditionals. 37. Replace conditional with polymorphism. Better don't. It usually doesn't justify the added complexity. 38. Introduce null object. Instead of checking for null, pass around null objects. Null objects encapsulate the behavior of what should happen when the object would be null. For example, print no result. Kind of dangerous because it might hide errors. Also, nobody expects the null object. Also, if you use inheritance, you might end up with weird behavior. 39. Introduce assertion. Express an expected state with an assertion to ease debug, making method calls simple. 40. Rename method. When the name of the method doesn't reveal its purpose, rename it. 41. Add parameter. Add the parameter when needed, kind of basic for a refactor technique, but here it is anyway. 42. Remove parameter. Remove parameters that are no longer needed. 43. Separate query from modifier. A method that returns a value also changes the state of the object. A clear violation of command and query separation. Create two methods, one for the query, one for the command. 44. Parameterize method. Several methods do similar things but with different values inside the method of the body. Replace them with a value that uses a param. Increase hit by 10%, increase hit by 20%, replace them with increase hit and percentage. 45. Replace parameter with explicit methods. A parameter controls the flow of your method with conditional. Create a method for each value of the parameter. The opposite of the last one, use according to context. 46. Preserve whole object. You are getting several values from an object and sending them as different parameters. Send the whole object instead. 47. Replace parameter with method. You invoke a method, then pass the result as a parameter. The receiver can also invoke this method. Remove the parameter and let the receiver invoke the method. On one hand, it's good, you have less parameters. On the other hand, this will increase the coupling of the method and probably reduce cohesion. 48. Remove setting method. A field should be set at creation and never change. Remove its setter. 49. Hide method. A method is not used by any other class. Make it private. This should only happen after refactoring. Methods should be as hidden as possible on creation, preferably private. 50. Replace constructor with factory method. You want to do more than simple construction when you create an object. Replace the constructor with a factory method. 51. Replace error code with exception. A method returns a special code to indicate error. Throw an exception instead. 52. Replace exception with test. Check inside the caller rather than checking inside the callee and throwing an exception. Defensive programming is a code smell, unless you are working with data from users. Refactoring techniques, dealing with generalization. Warning, there is inheritance ahead. Use composition instead. 53. Push up field and method, pull down field and method, move members up and down when it makes sense. 54. Extract subclass. A class has features that are used only in some instances. Create a subclass for that subset of features. 55. Extract superclass. Two classes have similar features. Extract a superclass with a common feature. This is how it lures you in, and then it ties you down and then you drown. 56. Extract interface. Several clients use the same subset of a class's interface, or two classes have part of their interface in common. 57. Collapse hierarchy. A superclass and subclass are not very different. Merge them together. 58. Replace inheritance with delegation. A subclass uses only part of a superclass's inheritance or does not want to inherit data. Basically, composition of an inheritance extended. Create a field for the superclass, adjust methods to delegate to the superclass, remove subclassing and enjoy composition. The problem here is a violation of least-scope substitution in most cases. 59. Replace delegation with inheritance. You're using delegation and are often writing many simple delegations for the entire interface. Make the delegating class a subclass of the delegate. Why would anyone do a thing like this? I don't know. 41. Refactoring techniques, big refactorings. 60. Tease apart inheritance. You have an inheritance hierarchy that is doing two jobs at once. Create two hierarchies and use delegation to evoke one from the other. Delegation is about the same notion as composition. 61. Convert procedural design to objects. You have code written in a procedural style. Turn the data into objects, break up the behavior, and move the behavior into the objects. 62. Separate domain from presentation. You have GUI classes that contain domain logic. Why would someone do something like this? I don't know. Separate the domain logic into separate domain classes. 63. Extract hierarchy. You have a class that is doing too much work, at least in part through many conditional statements. Create hierarchy of classes in which each subclass represents a special case. Sketchy because of inheritance.